Assalamualaikum, selamat pagi. Hari ini kita selesaikan soalan 14 Thermochemistry. Untuk soalan 14A, diberi standard enthalpy change combustion for ethanol is enthalpy formation of ethanol is negative 277.8, enthalpy formation water negative 285, and CO2 negative 393.5. And then given this, then we need to find the combustion of ethanol. The combustion of ethanol is in the oxygen producing 2 mole of CO2 and H2O. So here question us to find the standard enthalpy change combustion. According to definition, standard enthalpy change of combustion, it is when 1 mole of substance burn. Okay, so the 1 mole substance burn is the ethanol. Okay, so 1 mole of substance ethanol. And then this is our target equation because we want to find the enthalpy of the combustion of ethanol. Okay, we can use the formula because we are given the enthalpy combustion, enthalpy formation of ethanol, water and CO2. So our product is CO2 and H2O, CO2, H2O. That means 2 CO2 plus 3 mole of H2O, enthalpy formation of H2O, minus the reactant. So our reactant is ethanol and oxygen. The enthalpy formation of oxygen is 0, while ethanol is negative 774.8. So this is the total enthalpy of the product minus total enthalpy for the reactant. Finally, the enthalpy combustion of the ethanol is negative 1366.9 kJ per mole. Okay, meaning that for 1 mole of the ethanol burn in excess oxygen, it will release heat by negative 1366.9 kJ per mole. Okay, next is we are given the mass of spirit lamp and ethanol and water heated. Okay. In this case, the amount of heat the spirit lamp burn, the ethanol for the spirit lamp burn is 1.49 gram. So 1.9 gram of the ethanol burn is equal to 0.0413 mole of ethanol burn. The amount of heat released by the burning of this ethanol will release to the water. Okay, and then the water absorb the heat release. So question us to calculate the increase in temperature for the water used. Here is how many heat absorbed by this water. So we can determine from the enthalpy combustion of water that we calculate before, 1 mole of ethanol burn will release 1366.9 kJ heat. If 0.0413 mole of ethanol burn, then how many heat released? It is equal to, by using cross multiply, from this ratio we can determine for 0.0413 mole of ethanol burn, it will release 56.45 kJ heat. Okay, the heat really absorbed by the water is calculated by MC delta T. M is referred to the mass of the water. C is the specific heat capacity of water, and delta T is the change of the temperature. It's equal to the heat absorbed by the water. So here is the heat absorbed by the heat absorbed by the water is 56.45 kilojoule. It is equal to 250 gram of the water. Why is it gram? Because this one is centimeter cubic. Density dia 1 mole, 1 gram is for 1 mil. So 200 mil, 250 gram. This is the specific heat capacity and the heat change. So kita dah dapat delta T dia sama dengan 54.02. Maksudnya suhu at T1 of the water until T2 increase after absorbing heat from the ethanol burning, it will increase by 54.02 degrees Celsius. So that's all for question 14.